In 1874, Vaillant was founded by Johann Vaillant, making pumps in Germany. In 1899, the Buddy logo was introduced by Johann Vaillant. In 1905, Vaillant produced their first bathwater heater, and in 1924, Vaillant introduced their first central heating boiler, becoming the first to make the combi boiler in 1967. In 2001, Vaillant became a group, joining forces with companies such as Glowworm and Sonia Duval. This Ecotech range we're going to be looking at behind me here was introduced in 2006, but was revised in 2012. Now, the 2006 to 2012 had a few revisions as well. So on the data badge you will see R1, R2, R3, so on, and that tells you the revisions of the boiler. So, on all inside a boiler casing, let's get on with it. Now this Ecotech Pro 28 we're going to be working on is a 08 model. So, quite an old boiler, but they're still building them exactly the same for the Ecotech Pro and Plus range. So what we're going to do is, like all inside a boiler casing, we're going to start at the top and we're going to work our way down. So let's have a look at that now. So this is the flue at the top of the boiler, and this is the flue turret. So these are our sample points. If I remember correctly, this is our flue gas analysing, and this is our flue integrity testing. So this is where we would do our test. Now I quite like the design of the turret on this one because you can connect vertical or horizontal on it by just using a clamp. Now this is a gas sensor, this is the wrong clamp. This should be about half the size of this clamp. You can also see here, all Vaillant and Glowworm boilers require screws in the flues. They require them here and here, and they also require them in two places here and here, which they're not screwed. You can also see this boiler in the past has had problems with the flue seals leaking. Okay, so that is the top of the boiler. Basically that's all there is. It's the flue turret, the analyzer test points, and the flue itself. And again, this can flue pretty much anywhere because the test points always stay at the front, which is a really good idea on any boiler, that the test point stays where it is, which allows you to do 360 with the flue. When they put them on the actual elbows up here, it restricts you when they're on the side. Okay, so let's get this front cover off and let's have a look inside. Okay, now the first thing we can see is this black thing here. This is where the air for combustion comes in. This is a silencer. So air for combustion comes in here, it then goes along. This is a filter to filter out any bugs or anything like that. And then it goes down and into the back of the fan. So again, we'll have a look at that closely when we get it off. So the first thing you see is this silencer. Now behind the silencer, this is the burner. This is the burner door. This is a Giovanni, however you say that. Then this is our spark electrode HT lead with that earth wire. This does flame rectification as well as ignition, and that will go back down to the board. Okay. So to the right, the silver thing we can see here is our expansion vessel, which takes up the expansion of water. So water expands from 4 degrees to 100 degrees by 4%. And then over 100 degrees, it expands by 1600 times its own volume. So that's steam. And then from 4 degrees to minus 260 degrees, it expands by 10%. So all our expansion has to be taken up by this vessel because it's a sealed system, not a vented system. So this is what's called the Schrader valve, and this is where the air on this side, and then there's water on this side. We're going to show you later on in the video how to test this and how to take it out. So that's the expansion vessel. So if we move further down now, we can see the gas valve and we can see the fan. Okay, so gas is brought in through this stainless steel pipe here, and it goes into the gas valve, and then the gas valve is connected to the fan, and then the fan draws the gas in. This is a zero governor gas valve. So the faster this fan spins, the more gas it's bringing in. And then this is the burner tube where it's all blended before it goes into a cut burner which burns 360 degrees. This sticker you can see here, if you've seen any of our other videos, is a G10 sticker which tells us the burner gasket seal, which we'll have a look again closer when we take it out, has been replaced. But for some reason, like I say in the other video, nobody writes any dates on it when it was changed. According to the manufacturer, for the first 5 years, we don't need to take this burner cover off. Then after that, it's annually. And the gasket will need to be changed if we ever take this door off. But like I say, we'll have a look at that later. So as we come further down, we come into the water set. So let's start on the right hand side. This is our pump. Okay, and if you have a look at the pump closely, okay, you can see it's made for Vaillant by Grundfos. Okay, so it's a special pump. You can't just put any Grundfos pump on there. Behind there, what you can see where it's been leaking is the auto air vent on the back of the pump. And then this is the return pipe, okay, going up to the heat exchanger. When we take the burner door out, you'll see that more closely. Now, the thing you can see here is the 3-bar pressure relief valve with a handle to help us drain the system. If you pull that handle, it opens the actual pressure relief valve. Not a good idea really to drain a pressure relief valve because you get bucky systems and it damages them. So most boilers now put drains in rather than using the PRVs. If we come again to the left, this big shiny brass thing here is the diverter valve. Now this isn't the original diverter valve out of this boiler, this is a replacement one. And you can tell it's a replacement one by this electrical connection, what you get with it. So this is one of the new universal ones which will fit all the pros and pluses. So you get this universal connector. So the next thing we've got along here is our cold water flow turbine. So cold water comes in here, makes a little turbine spin round with a Hall sensor, and the Hall sensor senses that the water's flowing and tells the boiler to fire up. Next one along is the hot water pipe. Okay, so that goes off to feed the taps from the plate to plate, because this big silver thing you see here is a plate to plate heat exchanger. Now this is an NTC thermistor which tells the boiler what the temperature is of the plate to plate. So they're in the plus range of this is a pro, but in a plus range they have another NTC on the hot water out here. The thing we've got here now is the troublesome low water pressure sensor. Again, when we have a look at this a bit more closely, I'll explain more about this. But this now has actually been moved from this position because it has been troublesome up into the top around here. But again, once we get this burner out, we'll have a look at that. Also, what's inside here, again, when we strip it, we'll see it. There's a filter which can also be troublesome. Okay, so that's the water set to the hydro block down at the bottom. Okay, so first thing I've got to remove is this air inlet. So again, like I said, this is where the products of combustion come in. So I need to remove this first to get at the nuts for the burner. So it's just basically a Phillips screw. Drop it down and it comes off. As simple as that. So that's the first thing to get off. What I need to do now is take off the HT lead. Now, earth wire comes off first, but remember, before you do any work inside a boiler whatsoever, you must follow the safe isolation procedure and use your non-contact voltage indicator pen to make sure this isn't live before you touch it. It could save your life. Okay, now, earth's off, HT lead. Now, depending on how old this boiler is, then these can become very, very brittle. So when you're pulling them off, they can actually break inside, but the worst one is when you're putting them back on, because they're very, very stiff to get on and off. So just watch out for that. You could actually end up breaking the HT lead on that. Now then, all we're left with now is the gas connection. So let's get the gas connection undone, and then we've got these 4 nylock nuts to remove. So let's get on with that. Now, to undo these 2 nuts here, we need a spanner and a set of grips. So basically, grips on one nut, spanner on the other. We'll just undo them. And then inside here is a washer. This washer will actually need to be replaced every time you take the burner door cover off, or every time you break this connection. So this does come in the kit when we do replace the burner gasket. So that is the gas connection disconnected. The gas is not connected to this appliance, but you would need to isolate it down at the bottom here. Okay, there is an isolation underneath, you'll see that soon. Now all we need to do now is get a 10mm ratchet and socket and get rid of these nylock nuts. So let's get on with that. So let's get these 4 nylock nuts off. So basically we need a socket, 10mm, and a ratchet. So we've got this one to get off as well. Now before we actually remove this out of here, we've taken the nylock nuts off. These nylock nuts will need to be replaced every time you take this burner door off. So before we remove that, we need to remove some electrical connections. We've basically got one on the fan here, and we've got one on the gas valve here, and that's it. Okay, now this should pull straight off. Which it does, okay? So you can now see the burner in all its glory. So let's have a closer look at this burner now. Now let's have a look at this heat engine more closely. So now you can see the gas pipe where it came in, and it goes onto the back of the gas valve. So you can now see the gas valve more closely. So these are the test points here. One of them is the inlet test point, which is this one down the bottom here, and this will tell us our inlet test pressure. The one at the top will give us a minus reading, which is no good to us because the manufacturers don't tell us what those readings should be. Now this is where we adjust the ratios. So behind this sticker is where we would use the Allen key to adjust our ratios using the flue gas analyzer. Now you should never really adjust the ratios on these burners unless you're changing it to LPG or your readings are out and you've done a full strip down service. You won't just rack up to this boiler, find out it's analysing incorrectly, and then start adjusting it without actually finding out why it's gone out. This is where our air comes in for combustion, so this is where our silencer connected, and it connects all onto the fan. So this is the fan, you can see here, which is then the speed of the fan, like I said, draws in the gas into this blending tube. So if I flick it over, you can see the burner now. So you can now see the cup burner more closely. So again, burns 360 degrees. This is insulation, okay, to stop the front door getting hot. And this is our spark electrode. So our flame rectification, flame conductance electrode. Now this is the gasket, what needs to be replaced every time we take this burner door off. You can see there's actually a joint in it. So every time you open it up, you'll need one of these gaskets. Cost about 20 quid. So that is our full heat engine. So now we've got that out, let's have a look at the bottom of the boiler more closely and look at this water set. We can also see inside this heat exchanger now. So these are what we call a 2-pass heat exchanger. So there's 2 lots of flown returns in here in a coil, and there's 10mm stainless steel pipes. So you can see how close they are together, and we need to make sure that they're all clean and the products of combustion can get through, because they actually go through those gaps. This again is another heat shield on the back here, and this is actually where the cup burner touches. So the cut burner goes right the way to the back and burns 360 degrees around here. The condensate then drops down to the bottom and then comes out through this tube here. Okay, now I've been to a few of these in the past where this has actually fallen off. So the fix for that one would be put a Jubilee clip on it. Another one of the problems with this condensate pipe is you can see this is a rubber tube, and we'll talk about them in a minute, but when we change this to fully copper, because these are a problem, it's actually melting the plastic here. So Gas Safe issued a technical bulletin on this, so when you do service one of these old Pros or Pluses, you've got to make sure, if this is a copper pipe, that this plastic isn't touching it or it will melt the condensate through and will actually rot the bottom of the boiler out. So you can see there are two rubbers. There's one here on the flow and this one's on the return. Now there's no water in this, but it's quite flexible, these. They're not rock hard. Now they would be rock hard. They need changing. They're useless. They were put in originally to help sound reduction and when the water's flowing through, but have just become a massive big pain and leak constantly and split. So you've also always got to change, you've always got to change them. If they're fine and the customer don't want them changing, they don't have to, but you would always advise your customer to make sure that they get checked and changed. What we've got here are the thermistors, okay? So this is the one on the flow pipe and then this is the return pipe. And you can see the wires are colour coded red and blue, so you get them on the flow and the return. Okay, so it's important that they stay the right way. Taking this heat exchanger out is dead easy. There's just some clips and these 4 screws on the front here, but we ain't going to be taking it out today. So you can see at the top here where the air comes in for combustion and then goes round the side and then gets drawn in through the silencer. And you can now see this water set a lot more closely and you can see the plate to plate better now. Okay. So right in the corner there is the actual trap and you can see how much that's been leaking as well. So this would have been on a really dirty system. And you can see our copper pipe now, which is going up to our expansion vessel. These can also be a pain in quite a few boilers. If they're a flexible hose, they get blocked up as well. So flexible hoses aren't very good inside boilers because we like to put brand new boilers on 30-year-old systems full of muck. So that's another tour around. So let's actually get stuck in and start taking like we do normally on inside a boiler casing, and let's get this pump off. Now to remove this pump is pretty straightforward. We're just going to take the head off first. But remember, before you do any work whatsoever on the wet side, the water set, you would need to isolate the valves underneath on the flow and return or the cold water coming in, drain the water through the taps and then drain the boiler itself through the drain. So we'll have a look at that when we look underneath later. So there's no water in this boiler, so this is dead easy to strip. So all it is now is a matter of undoing the 4 Allen screw bolts there holding it in. Now, as you can see, this pump is pretty solid. So it's not had any water in for a while. The pump actually looks in good nick, but you can see how solid that was. Now this is hardwired onto the PCB, so we can't, well, we can undo the wiring from here, but it's just as easy to unplug it from the PCB, so you could do it either way. So that's the pump out. Next thing we're going to look at is the diverter valve. Now the pump head's removed, we can see the diverter valve more closely. So the main thing we need to do with the diverter is remove that screw, and there is also an awkward screw underneath there somewhere, if you can see it. Just see it in the background. They actually got Phillips head screws or flat screws. Sometimes they can be seized, sometimes they can be dead easy to get off. Also, what we've got to do is remove this pin here, and we have to undo this nut here. This, what you can see here, is the automatic adjustable bypass. When we take the diverter valve off, you'll see where that connects onto. And this is the head, the motor. We're going to strip that off to have a look at that. So first thing to do is get these 3 screws out. So we also need to remove this which is a clamp which holds the diverter onto the pump body. So that's out now. Let's get these screws out and let's get it stripped. So let's first undo this nut here. Again, this is the water set. Again, this is no water. Again, you would have to drain this. So it's the matter of undoing the nut, he says. Inside here is a washer, which we'll need to change. Now we're not going to take the pin out yet, so we're going to leave that off. I'm going to disconnect the wiring. So that's, again, just the clip, he says. Just undo that clip. Okay, I'll explain the difference in these in a bit, so we'll see that in a bit. So I need to get these two, well, 3 screws out now using a screwdriver. So, okay, now inside the hole there, you should be able to see the motor and how we can get it off. So if we look at this here, this clamp, so you can see how it's shaped. Actually, if I push the shaft back, you should be able to see it. You can see the little ball on the end of there. So that little ball clips onto this. So it goes over the top and clips up. So it can now drive the motor in, well, the motor drives the shaft in and shuts off the diverter valve. So if I push the plunger up, so that pushes and closes off the port to allow the water to go around the system. So now we've got that off, we can have a look actually at the plate-to-plate heat exchanger. So this can go into 3 positions. It can go mid position, which is in the center, which allows you to have heating and hot water. If it goes all the way out, that allows it to go through the plate-to-plate heat exchanger. And if it's shut all the way across, it allows the water to come through here and go back into the heating circuit. So the heating circuit would flow through here, come through here, and then go through into the pump. Okay, so that's how the water would return. So coming up through here. Now the other hole here is the automatic bypass. So let's have a closer look at the plate-to-plate. Now we can see the ports where the diverter fits onto. So this is where our automatic bypass would come through. And this is where it would blank off, so the plunger would push against here and shut the port off to the plate-to-plate. And then if it wanted the hot water, it would open up and the hot water would, well, the central heating return water would come back through this way. So it would go through the plate-to-plate on the other side, come across, so this is the flow. So it would go down, go into there, go through the back of the plate and come out of there and back into the pump, and then making its way around. So that's the diverter valve, dead easy to change, but they're very expensive. But I do believe there are some kits you can buy on the internet to change the insides of the diverter, but I always replace. So next thing we're going to look at, which is just to the right of the pump, is the pressure relief valve. Let's get on with that. Now before we can remove this, first of all what we've got to do is we've got to come underneath here and undo this nut here to take this piece of pipe off to be able to remove it. Let's do that first. Now the pipe's off, so let's go back up to the top. Let's get a flat screwdriver into that clamp and take that off. Now let's just lift that clamp up, get rid of that. Now this should just pull forward and come out. That's pretty easy. So that is our 3-bar pressure relief valve. Okay, dead easy to change. Okay, so I've put a few things back in again. So you can see now how we're going to take off the crusty automatic air vent. So first of all, we need to get a flat screwdriver and prise this bar forward so it comes all the way out. Okay, and we need to get some grips on the flats what are there, and this should come up. You can now see the O-ring, and you can see how crusty that is. So the way these work, dead straightforward, is when it's down like that, that means it's completely full of air, and when the slides up, the water pushes it up there and pushes the valve off. So that means there's air coming out the bleed at the top, and when it's up to the top like that, that means it's full of water. Now you can see how crusty it is. This is the biggest problem we have as heating engineers, is repairing boilers on dirty systems. So guys, make sure you always flush and clean your systems, or this is what happens to automatic air vents. Let's get this back in and let's have a look at some other parts. Now, a top tip before you put it back, I'm just going to use some silicone spray on the O-ring, because this will make it a lot easier to get back in. So before you put your O-rings back and your parts back, if it has got a rubber O-ring, always make sure you lube it first. So this should make it incredibly easy now to get back in. So there you go. How easy was that to get back in? And the hardest bit now is to get the clip back in the right place. There you go. Made it a little bit harder than it was, but there you go, it's back in. Okay, next thing we're going to remove is this little puppy, which is the cold water flow turbine. What this does is, as the water passes through, there's a little turbine with a hall sensor. You can see the wires coming off the bottom of the hall sensor, but again, when we get it out, we'll look a bit closely. What that does is, it tells the boiler that there's water flowing through it. So, get on the Vaillant, dead easy to take off. Just need to undo this nut first. Okay, so that's that. Then the next thing we need to do is take this clamp out. Now, you should be able to get it with your fingers, but it is just as easy to rise up like that. So, oh, and it shoots you in the eye. Okay, now we can just pull it forward, undo the wires, and then that's out. So let's get the wires undone, because I do need two hands, and we can look at it closely. Okay, the cold water flow turbine. So you can see that is where the cable goes. Okay, this is where the water comes in and the water goes out. So if I blow through here, you can hear the turbine spinning inside. Okay, now this is a complete unit. This clamp is only holding this brass section on here, so if I undid the clamp, this brass section would come off. Now again, this is an O-ring, so I'm just going to lube the O-ring up and put it back in position. This is just a standalone change unit. The fault you would get with this is, if you open the tap and the water was running and on the display there was no little tap symbol, that would give you an indication that there's something wrong with the flow turbine. If there is a little tap symbol on the display when you've got the tap running, then it's not the flow turbine, it could be the diverter valve or something else. But this is how you can tell whether it's working. On the front panel, a little tap will come on when the water is running. So, another one of Derek's top tips. So let's get this O-ring lubed up and back in. Now, next part we're going to remove is this troublesome low water pressure sensor. This has had a few upgrades. The first ones what came out were a pink colour. This is one of the newer ones. I think they've had about 3 series of them. And they're that troublesome, blocking up with, again, dirty systems. Vaillant moved them to the top up here. So they're now, this is the flow, this is the return. I'm almost certain they're on the return, but I might be wrong, but I'm sure they're on, yeah, I think they're on the return. Because what this also does, as well as low water pressure, it also proves the pump's working and it also gives you your digital display for your pressure reading. So kind of 3 things in one. So again, dead easy to remove. First of all, let's pull the wire off while we've got the pin still in. And we've got another little pin. My screwdriver might be too big. No, it did it. Pull that pin out, and then the little beggar should come forward. Okay, again with an O-ring. So what happens with these is all the debris goes inside there because there's a little pressure switch inside there. Some guys I've seen bypass them by putting screws in and all sorts, but dead easy to replace. The only problem you get is lots of water coming out there. Now there's another troublesome bit inside there, which is a filter. I'll put a picture on and explain that later because I'm not going to strip that bit. So, low water pressure sensor. Let's get it back in and move to something else. Next thing I want to talk about is this little thing here, the expansion vessel. Now, as I said early on in the video, this side is full of air, this side is full of water. Now, I've talked about the expansion and how it works. Now, when you come to service these boilers, not every guy checks the pressure in these because it is a bit of a pain. Now, one of the things you can do is, if you tap one side, tap the other side, they should have different sounds because one's got water in, one's got air in. But if they both sound exactly the same, then you've got some problems. Now, if this does fill up with water, this Schrader valve here, which is the same as what is on your bike tyre or your car, again, if I press this in, and air comes out, then I know there's some air in there. But if I press that in and water comes out, then I know we've got a problem. Okay. Now, the major problem with this is if the diaphragm has gone inside, or it has lost its air, what would happen is the water would blow off on the pressure relief valve because there's no way of taking up any expansion. Okay. Now I'm going to show you how to take this out. The one thing you must be careful of is these will weigh an absolute ton when you take them out. Now, a litre of water weighs 1 kilogram. So these could be weighing up to 20-25 kilograms on some of them, so be very, very careful. That's why on unvented cylinders, if you go and do any repairs on that, the expansion vessel falls off the wall, because people don't realise they need to be secured. Now, all it is 2 securing here and the nut here. But I want to talk about this hook while I'm here as well, because you know, these little things make me happy. Now, what this hook is for, if I find the burner, I'll get the burner. What this hook is for is when you take the burner off, you can hook it on and it keeps it safe for you. What a great idea that is. But it's in the way now, so I'll take it off. Now, first thing I'm going to do is undo the water connection. Just get a spanner. I'll just open it up. Again, there is an O-ring in here. And I'm just going to undo these 2 screws, Phillips screws at the top. Now, because I've taken this off, this will become very unstable. Place it on the top, and now this will slide forward. How easy with that? So, should sound the same, because they both got air in, there's no water in that, how light it is. Okay, so I'm going to put it back in, and then I'm going to show you how to check the pressure in it. So let's get it back in. Now, to check the pressure in this vessel, I'm going to be using this little baby. I love this little gadget. 39 quid from Lidl, Parkside. You can have that advert for free, Lidl. Okay, so, plumbers, gas engineers, we all need one of these. Even if it's just blowing up your tyre on your van when it's gone flat. So, take the test nipple out. Now, when guys are testing this, a lot of guys make mistakes because they leave it full of water. So what you must do is isolate the flow and return underneath and then blow the pressure out using the pressure relief valve, which you shouldn't do, you should use a drain if a boiler's got a drain. So blow that water out, so there's no water on the side of the diaphragm, so it's at equilibrium. Then we just screw this in, get everything in the way. He says, losing all his air. Okay, so hopefully you'll be able to see that. But it's actually reading 0.5 of a bar now. I've actually got rid of some of the air. So what I'm going to do is I'm going to open the pressure relief valve to fill it up to 0.8 because this boiler requires 0.8 of a bar. So I'm going to open that up. 0.6, 0.7, 0.8. So that's now got the correct pressure in there because I've got no water on this side, I've just got air on that. If you put too much air in, the water can't compress it, and if you put too little air in, then the expansion will be taken up inside the boiler and blow off on the pressure relief valve. Now, I'm going to be quick getting it off. Okay, now, Derek's next top tip, leak detection fluid. Flood the boiler and actually check and see if the air's coming out. Okay, that was me pressing my finger in there, by the way. So that's not bubbling, so it's not passing. I can put the cap back on, and that's now set up and ready. Okay, so that's the expansion vessel. Now, for the last part of this video, I just want to have a look underneath the valve set at the bottom, like we always finish off and inside a boiler casing. So let's have a look at that now. Okay, so we're underneath the boiler. This is the data badge of the boiler. So from the serial number, you can see it's an 08, and it's a revision 1, this one. It's an Ecotech Pro 28 R1, means revision 1. So as usual, let's start on the left hand side. This is our flow pipe, isolation and drain. This is our hot water. This is our gas with a isolation point. No inlet test point. This is our cold water inlet. Now if this was a plus, there would be a filling loop going from here into this side here. But this is a Pro, so you'd have to have an external filling loop. And then this is your return. Now this is the blow-off pipe. Now one of the things, this comes as a set length and you shouldn't cut it, because if you do cut it, you can't get this out. And this is the condensate trap. Now always again, another top tip, lube that up before you put it back up again. And if you lube it up and push it in, it'll twist on dead easy. This is your condensate pipe. Okay, so that's doesn't get in the way of that, but if you put that across there and then the pipe going out through the wall, you would not be able to get that out. So that's one of the things, and it's still like that on them now. So that's underneath the actual boiler itself with the valve set. Now that's our video on inside a boiler casing on this Vaillant Ecotech Pro 28. If you've liked this video, give us a thumbs up, or leave a constructive comment down below. If you've not subscribed to our YouTube channel yet, why not? And hit that notification bell, because we release videos every Wednesday. All what's left to say is, as usual, thanks for listening, thanks for watching, see you next Wednesday. Cheers.